quick, this is not something super new yet. We've got the slope is the constant rate of change. If you remember, it's that change of y divided by the change of x, the rise over run, the delta y, delta x, all that jazz. Same thing. If you remember even positive, negative, no slope, zero, easy. So what you should have learned in one of the more recent lessons, though, is you should have started noticing that the slope is always going to be the coefficient on the x. So right here, when you have this set up, m is always going to be next to your x like this. It's always touching it. It's that creepy coefficient. All right. Creepy. All right, so what's kind of new is the y-intercept. Hopefully we remember last year we did go over this a little bit. B is the y-intercept, but what we're now going to focus on is that the y-intercept is specifically where your line is intercepting the y-axis, hence y-intercept. Not only is that something we can identify with B, but we can identify this with a point. So, for example, in this one, if we say, well, B is going to be our y-intercept, let's pick a line. I'd pick this one because why not? Let's follow this line, see where it hits that y-axis. Goes this way, this way. Oh, here you go. This is where it crosses. This is where it intercepts. So right here, our B is going to be this -2 right there. So B is going to be our -2. That means our y-intercept is going to be a -2. Now, the other thing we want to focus on, though, is where is that point? On our graph, this is an actual place. It's an actual point. We know there's a -2 involved, and here's the thing. It's where y is -2. And we put this as x being 0. All right, so hopefully we remember this equation as well. Y equals mx plus b. So you've got your y and your x. Those are your points, or from your points. And then you've got m as your slope, your rate of change, b as the intercept. Notice that the b over here is our constant. We are adding the intercept, but multiplying the slope. For this one, let's just go ahead and identify these two parts of our equation. We've got our equation in y equals mx plus b form, or, slope intercept form, because it's got a slope and it's got an intercept. Go figure. Anyways, so y equals mx plus b, except our m looks like it's a 4 and our b looks like it's a 3. M is our creepy coefficient. Notice it's sitting here right next to the x. That is our 4. B is our constant. It's being added, plus 3. And again, our point here for y-intercept is always, the number itself is the y value. If you remember, our points are x comma y. But the x value here for the y-intercept is always, always, always 0. Always. Try this one out on your own. Pause it. Okay. For this one, you may have noticed that the slope, what?
The coefficient.
The coefficient, yes. For this one, the slope or the coefficient is a little bit more difficult to identify because you've just got this x. But what is always in front of this x? There's always that invisible 1. So we actually have a coefficient of 1, which means our slope is 1, and a constant of this subtract 6, or a -6. Notice that we took the sign in front of it with it when we identified the y-intercept. If we turn this into a point, which hopefully you did, y is this -6, and remember, wherever the y-intercept is, the x is 0. Okay, again, pause. Hopefully you identified m here is going to be this creepy coefficient right here touching the x. It's going to be your 3. B here, hopefully you didn't forget the negative because it is this entire thing here, our -2. And as a point, that's 0, comma, -2. Close parentheses. Pause again, and go. For this one, our slope here, the only difference is that now we have this negative up front. And again, we cannot leave those signs behind. So m equals a -7 this time. B equals, terrible writing, B equals a +9. Notice we don't have to put the plus sign, but we know it's there, which is the point 0, comma, +9. Again, pause. Another case where we do not have the coefficient, but we know that there's actually this ghost one right in front of it. M should have been your 1. B should have been the +2, or just a +2, which gives you the point 0, comma, 2. Ooh, okay, now let's switch it up a little bit. I'm giving you the m and the b, and you have to put this in slope-intercept form. You need to put this as your equation. Luckily, we have our little reminder right up here, so we've got y equals. Now, it starts with mx plus b, All we are going to do is replace the two parts with the things that we have been told. So let's go ahead and substitute in the m, which is 5, for m. We've got y equals 5 instead of m, x plus, and we're going to substitute in our negative 9 minus 9, or negative 9. Notice, we now have plus a negative 9 because we were going off of y equals mx plus b. That's okay. We can shorten this down. Y equals 5x. Remember, when you're adding a negative, what you're actually doing is subtract 9. There we are. Simplified. All right, pause. Try it on your own. And let's go. Y equals mx plus b. We're just going to substitute in the m for negative 2. Y equals negative 2x plus, and we're going to put that positive 8 here. Notice that the negative here is in front of the 2. We don't need to rewrite this as plus, or because it's not plus negative anything. It's just the negative 2 right up front. Please don't forget it, though. It is extremely important. Try it on your own. Okay, let's go. This one's a little bit trickier. Starting with y equals mx plus b again. Oops. Helps if you write it down correctly. Mx plus b. All right. M we're substituting in our 0. Y equals 0x plus a 17. But wait, we're not done. Because we happen to know that 0 times anything else is going to be a 0, which turns this into 0 plus 17, and we don't need to write plus 0. So this actually simplifies down all the way to y equals 17. Very easy way to identify your y-intercept. Plus? All right, for this one, the only difference is a fraction. Hopefully it didn't throw you off too much. We've got y equals mx plus b. Substitute y for the 1/2. X hasn't changed. Plus a 0. Okay, well, do we really need to say plus 0? We just went over this in the last slide. So this one actually simplifies down to y equals 1/2 of x, because the plus 0 is still there, and we know it's there, but we don't need to write it, because it's not super important for this problem. All right, pause. And let's go. Y equals mx plus b once again. Hopefully we remember for this one as well that if m is 0, this x is not going to stick around very long. Y equals 0x plus a 1, 0x, 0 times x, which is just 0. We don't need to write plus 0, so y equals that positive 1. Ooh, a fun one. Pause, and let's go. Y equals. So this is kind of a combination of the things we've seen in the last couple of slides. So we've got y equals a 0x plus 0. Well, we know 0 times anything is just 0. We know we don't need to write plus 0, but we need something on this side. We end up with nothing here. But it's actually a 0 plus 0, which still does give us a 0. So if there's nothing left on this side, we do still want to specify that this is a 0.